Intersecting lines. When you graph two lines in the same xy coordinate system, there are three things that can happen. One thing that can happen is the two lines can intersect each other somewhere. So they touch or cross. We also call that intersect. What do you think another thing is? If you're thinking they can be parallel, you're correct. Okay, so they could be parallel, which means they never cross. What's the third thing? Yep, they could be the exact same line. So these are the three things that can happen. We're going to look into how do you figure out where two lines intersect, or how do you figure out where they cross when this happens. Okay, so let's do an example. Find the point at which the line f of x equals 5x minus 8 intersects the line g of x equals 3x minus 6. Let's first graph these to get a sense of whether or not they actually do cross each other. And we're going to do a really quick graph. We're not going to do this super accurately. Okay, so the first line f has y-intercept -8 and slope 5. That means it goes through -8. And then we can go up 1, 2, 3, 4, 5 over 1 to get another point. So f looks something like this. Now g has y-intercept -6 and slope 3. So it goes through 1, 2, 3, 4, 5, 6 on the y-axis, -6, and then we go up 3 over 1 to get another point. Okay, so you can actually see based on how I just did this graph where these two lines cross. So if you graph if you have a pretty good graph, which I didn't even mean to do that good of a graph, but it ended up being good enough to see where they cross. So if your graph is pretty good, you can actually look and see where they cross. So notice that these graphs cross at 1, -3. So you can actually see from the picture they cross, or intersect at 1, -3. Now, what if you had more complicated equations, or what if they crossed in a weird spot that was a fraction or something like that? You don't want to have to graph the lines to figure out where they cross because it ends up just being a big pain. So what can you do instead? You can actually take each equation. So one of them is this, f of x equals 5x minus 8, and one of them is g of x equals 3x minus 6. And I prefer them to be in y equals form, so if you write it as y equals 5x minus 8 and y equals 3x minus 6, it's nicer. And what you can do is you can set the two equations equal to each other. In other words, if this first line has equation y equals 5x minus 8 and the second one is y equals 3x minus 6, I can substitute 3x minus 6 or this y value in for this y value here. So that is 5x minus 8 equals 3x minus 6. And then I can solve for x. And when I solve for x, it's actually going to give us exactly the x value where the graphs intersect. So we want to know, where do these two lines touch each other? Where are they the same? If they're the same, then their y values are equal. These y values are equal. In other words, 5x minus 8 is equal to 3x minus 6. So these graphs cross when 5x minus 8 equals 3x minus 6. If I add 8 to both sides here, I get 5x equals 3x plus 2. And then if I subtract 2, or not 2 actually, subtract 3x, I get 2x equals 2, or x is equal to 1. This is exactly the 1 that you see in this picture where the two graphs cross each other. How do we know what this y value is if we didn't want to graph? We could then take this 1 that we just found and substitute it back into either of these two line equations. So I can now plug x equals 1 into either y equals 5x minus 8 or y equals 3x minus 6. It doesn't matter which one, you're going to get the y value either way. So if I put it into y equals 3x minus 6, I get y is equal to 3 times 1 minus 6, or y is equal to negative 3. So algebraically, we can find that the two graphs intersect at x equals 1 and y equals negative 3. In other words, the graphs intersect at 1 comma negative 3. So if you don't want to graph your two lines to find out where they intersect, you can take a system of equations, or the two line equations, and then you can, if they're both in y equals form, like this, you can set them equal to each other. Another way of thinking about that is we're like plugging this 3x minus 6 into the y spot here. And then you solve for x. And then you plug this x value back into one of the original equations. And then you'll have both the x and the y where these two graphs intersect each other. So notice at 1 comma negative 3 up here in the picture, this is exactly where the graphs touch.